Hello guys, welcome back to lecture series on EM3. In our today's video, I'm gonna explain to you all some of the questions from variation of a parameter point, okay, which is most important here for finding the particular integral. Okay, these questions are very much important for the SPPU upcoming question paper, so you must have to prepare this question properly. Okay, so here we have the linear differential equation given here: d square y by dx square minus 2 dy by dx plus 2 which is equal to e raised to x into tan x. And we have to find out the complete or general solution using this differential equation, okay, linear differential equation. For finding the complete or general solution, first of all we go for finding complementary function, then we go for the particular integral, and we add them as a complete solution for our linear differential equation. Okay, so here let's proceed here with the complementary function that you all are familiar here. Complementary function, it is one of the easiest tasks for finding. Okay, so we work here for the complementary function. For complementary function, what we do, we convert this equation, differential equation, into the some sort of auxiliary equation. Okay, what we do, we convert given differential equation into the auxiliary equation. Okay, so convert it into the auxiliary equation. How we going to write? D square minus 2d plus 2, okay, which is equal to 0. This one is our auxiliary equation we have here. Okay, this one is our required auxiliary equation, and we have to find out the roots. Okay, find out the roots for this differential equation. So now see that sometimes it is quite confusing to find out the multiplication of two number 2 and their addition minus 2. Okay, so in such a case we have to apply standard form for finding the differentiation. Okay, so what do? We compare here a d square minus a d square plus b d plus c which is equal to 0. Okay, yes, so whenever we have this such a quadratic equation, we apply standard form minus b plus minus square root of b square minus 4ac upon twice of a. Okay, this one is the standard form, we apply it here. Okay, yes, now what we do, find out the abc value here. What is the a after comparison? A which is equal to 1, b which is equal to minus 2, and c which is equal to 2. Okay, replace all these values in given form. Okay, minus b means minus of minus 2 which is a plus 2 plus minus b square minus 2 square which is a 4 minus 4 times a into c. Okay, that means 4 times 1 into 4, and 4 times 2 is a 4 2s are 8. Okay, yes, upon twice of 8, 2 times 1 it is a 2 only. Okay, so this one is the just substitution of a value into this form, we'll get this one. Okay, so go for next calculation. So we going to write 4 minus 8 which is a minus 4. Okay, minus 4 square root of minus 4 2 plus minus square root of minus 4 by 2. Okay, now see that whenever we have under square root negative sign, that means there exists a complex square number. Okay, that is iota form. Then we write 2 plus minus square root of iota square as a minus 1 into 4. Okay, so this minus 1 I written as iota square. Okay, because it comes under square root. Okay, that's why. So iota square into 4 divided by 2 here. Okay, iota square, take it out here. 2 plus minus out of bracket iota and 4 means 2 square upon 2. Okay, that means we got the 1 plus minus iota. This one is the our required roots for our quadratic second order differential equation. Okay, this one is our quadratic equation. There here we have the roots for our equation. Okay, 1 plus minus iota. Then what is the complementary function whenever we have complex root? Then we write complementary function for our complex root: c1 e raised to ax. Okay, e raised to ax, c1 cos bx plus c2 sin bx. Okay, this one is our complementary function for our complex root. A and b which denotes a plus minus bi, that means a which is equal to 1, b which is equal to 1 here. Compare this one with both of them. Okay, so I got the a1 and b1. So replace here a1 b1. So e raised to 1x which is e raised to x, c1 cos 1x. Okay, c1 cos x plus c2 sin 1x, c2 sin x. Okay, we are not going to write 1 here. Okay, Okay, this one is our required complementary function. Now by using a variation of a parameter, we are going to solve it further. Okay, so complementary function, it is as the form, okay, e raised to x, take it inside, c1 e raised to x cos x plus c2 e raised to x sin x. Okay, yes. Now as we have complementary function in the form of c1 y1 plus c2 y2. Okay, yes, so compare both of them here. So we get the y1 as e raised to x cos x and y2 as e raised to x sin x. This one is a y2. Okay, so I got the value for y1 and y2. Using this y1 and y2 we are going to find out the value for particular integral. Okay, now let's work for the particular integral then. Okay, yes, for finding the particular integral, we know that for particular integral we write v into i1 u into i1 plus v into y2, okay, as our particular integral. For that we have to find out the value for u and v here. Okay, yes, particular integral can be written as u into y1 plus v into y2. Okay, so we have to work for y1 and y2. So y1 can be written as integration of minus y2 into x divided by Wronskian w dx. Okay, yes, in earlier my previous lecture I explained what is the x. Okay, the value for x which gives us the e raised to x tan x. This one is the value for x. Okay, yes, we have x. Wronskians I'm gonna explain to you all later on. Minus y2 you can take it, that one here. Okay, into dx, and y2 u. Okay, this one is a u. Okay, this one is a u and this one is a v. Okay, integration of y1 into x divided by w dx. Okay, this one is our v. Okay, we need u and v in order to substitute here. Okay, so for that we need Wronskian first. So how I'm going to solve Wronskian here? Now see that this one is the y1 term, this one is the y2, this one y1 dash, this one is the y2 dash. Okay, replace the value y1 y2 y1 dash y2 dash. Okay, so we have here y1 as a e raised to x cos x, e raised to x cos x, y2 e raised to x sin x. Okay, so y1 dash, we have to apply by-part rule here for finding the differentiation. Y1 dash we want it here. Okay, this one is the actual Wronskian. Okay, yes, now see that as we have product function, so by-part rule for differentiation, it says that keep first function as it is, differentiate second, plus keep second function as it is, differentiate first. Okay, so e raised to x as it is, differentiation of a cos x, differentiation of a cos x which is a minus sin x. Okay, minus sin x plus cos x as it is, differentiation of e raised to x, it remain e raised to x only. Okay, so we have e raised to x cos x, e raised to x minus sin x. Okay, again differentiate this one, e raised to x as it is, sin, differentiation of sin x which is a cos x. Okay, again cos x as it is, differentiation of e raised to x is a e raised to x. Okay, yes, this one is our next step. Now go for the cross multiplication and calculations. Okay, what we will get here, e raised to x cos x into e raised to x cos x plus e raised to x cos x. Okay, now see that e raised to x cos x plus e raised to x cos x, that means what we will get here, so this one is not a cos, this one is a sin x. Okay, because we are taking e raised to x as it is, differentiation of a sin x which is cos x. Okay, and after that we are taking sin x as it is, differentiation of e raised to x, it remain e raised to x. Okay, now let's go for further calculation. We have to reduce it into the simple form. This one is actual 2 by 2 determinant. Go for solving this 2 by 2 determinant. Okay, e raised to x cos x multiplied by this term. Okay, e raised to x cos x plus e raised to x sin x. Okay, this multiplied by this minus this multiplied by this. Okay, so e raised to x sin x which multiplied by e raised to x cos x minus e raised to x sin x. Okay, e raised to x cos x, e raised to x, e raised to x sin, e raised to, now what we are going to do here, we are going to multiply these two terms here. Okay, after multiplication of this we are going to multiply this one here, e raised to x sin x multiplied by e raised to x minus sin x and e raised to x cos x. So e raised to x cos x minus e raised to x sin x, e raised to x sin x. Okay, yes. So go for expanding the term. Okay, multiply similar term under bracket, so it is easier to remove the terms from here then. So e raised to x cos x into e raised to x cos x. So we write e raised to x cos x. It is a 2 times multiplication for e raised to x cos x here. So what we do, keep e raised to x as it is, take that e raised to x outside here. So we will get the e raised to x into e raised to x. Cos x take under bracket here, cos x into cos x. We get the cos square x plus sin x into cos x. Cos x into sin x. Okay, this one is the term under bracket here. I am multiplying that cos x here and here. Okay, minus. Again, what we do, take e raised to x common from all the terms. E raised to x into e raised to x. This one as it is. This one common here between from this. Okay, multiply sin x under bracket. Sin x into cos x. Sin x into cos x here minus sin x into sin x, which is a sin square x here. Okay, yes. Now see that what we have here, e raised to x into e raised to x. Base same, then add their power. That means which is e raised to 2x. Again e raised to x into e raised to x, e raised to 2x. These two terms are common here. Take it outside. So I'm going to write e raised to 2x here. So under bracket cos square x plus cos x sin x. Cos x sin x. Multiply under bracket here minus sin x cos x. Sin x cos x. Okay, minus minus plus sin square x. Okay, now see that plus term minus get cancelled. Okay, cos square x plus sin square x, which gives us the value 1. So we get the only e raised to 2x. Okay, this one is our required Wronskian. I got the Wronskian over here. So what we want here, we want the value for u and v. So substitute Wronskian here, the value for x here, y1 and y2 over here. Okay, then what we will get in our next step. So next task is to replace all the values here. Okay, so how I'm going to write u here. Now see that what we have u. Okay, u can be written as minus of integration of y2. Okay, so replace the value for y2. So as we have y2 which is equal to e raised to x cos x. Okay, let me explain to you what is the y2. We got it here in our previous step. Okay, let me explain here. We got the y2 over here, e raised to x sin x. Okay, so replace this y2 here, e raised to x sin x, y2 into x. Into x means e raised to x tan x. Okay, into e raised to x tan x, y2 into minus y2 into x divided by Wronskian. What is the value for Wronskian? E raised to 2x. Okay, dx. Now we are going to solve it further. Minus of e raised to x, e raised to x. Okay, so we have multiplied e raised to x into e raised to x. It goes e raised to 2x. That cancel with this e raised to 2x. Okay, so we left here with the term sin x into tan x. So sin x keep as it is. Tan x I'm going to write as a sin x upon cos x. Okay, dx minus sin into sin x upon cos x. So what you do, you can keep tan x as it is, as we have standard integral over here. Okay, we can get the directly answer. Yes, so sin x. Okay, sin x into sin x we have here upon cos x it is here. Okay, so the next value we have here, sin x into sin x upon cos x. Let's go for solving next step. Sin x into sin x, which is a sin square x. Okay, sin square x upon cos x here, which is a dx. Okay, yes, so we are going to extend this step further. Okay, so what we write here, integration sin square x. We know that sin square x can be written as 1 minus cos square x. You all are familiar with the result sin square x plus cos square x, which is equal to 1. Okay, we want the sin square x. We want the sin square x which is equal to 1 minus cos square x. Okay, replace here 1 minus cos square x. Okay, upon cos x. So what I have done here, I just replace sin square x as a 1 minus cos square x here. Okay, yes, so what we do, we are going to take integration of this step further. So next step I'm going to write here minus, keep as it is, 1 upon cos x. 1 upon cos x can be written as sec x. Okay, 1 upon cos x can be written as sec x minus cos square x upon cos x, which can be written as only cos x. Okay, sec x minus cos x dx. So we have to take the integration of that term further. Okay, so how we write, sec x minus cos x dx. So I'm going to write integration of sec x dx. Okay, we are going to write integration of sec x dx minus integration of that minus sign out here. Okay, that minus sign out here. Okay, and the integration of sec x dx minus integration of cos x dx. I'm going to write this step over here. Okay, yes. So minus keep as it is. Okay, integration of a sec x. Okay, what is the integration of a sec x? Integration of a sec x is a log of sec x plus tan x. Okay, integration of sec x, which is a log of sec x plus tan x. Okay, this one is the integration. So I'm going to replace here log of sec x plus tan x. Okay, this one is the integration minus, okay, integration of cos x. Okay, the integration of cos x, which is minus sin x. Okay, integration of cos x, which is the sin x. Okay, so what we have, integration of cos x, which is the sin x, keep that negative as it is, which is the sin x, this way. Okay, take negative under bracket, negative of log of sec x plus tan x. Okay, negative positive sin x. Okay, this one is our value for u. Okay, yes. Now let's go for finding the value of phi. Okay, I hope you all have understood this entire process. It is little bit calculation, but I simplified it into the simple form first, and then I got this value of u. Okay, so the value for phi can be written as integration of y1 into x upon w dx. Okay, yes. So put the value for y1. So what is the value for y1? E raised to x cos x. Okay, yes. So put the values over here, e raised to x cos x into we have capital X as e raised to x tan x, capital X as e raised to x tan x under integration Wronskian, which is the, what is the value for Wronskian's? E raised to 2x. Okay, dx. That e raised to x into e raised to x, that means base same there, add their power, cancel with the denominator. Okay, so we write integration of cos x multiplied by sin x upon cos x. I just expand tan x as a sin x upon cos x. Okay, into dx. So cos x can be cancelled here. Integration of a sin x dx. Okay, okay. So integration of a sin x. What is the integration of a sin x over here? Okay, so what we have, e raised to x cos x up into e raised to x tan. Okay, so it is a simple here, integration of sin x, which can be written as integration of sin x, which can be written as minus cos x. Okay, this is the value for phi. Okay, so we want the particular integral. So particular integral can be written as u into y1 plus v into y2. Just replace the value for u, y1, v, y2. Okay, so what is the value for u? Minus log of sec x plus tan x. Okay, so right here minus log of sec x plus tan x. Okay, this one is value for u. Okay, and plus sin x it is remaining. Okay, this one is the entire value for u. Okay, multiplied by y1. What is the value for y1? We have here e raised to x cos x plus after that we want the value for v into y2, v which is a minus cos x. Okay, into y2. What is the value for y2? E raised to x sin x. This one is our required particular integral. Okay, so if you want complete solution, okay, if you want complete solution, write complementary function plus particular integral. Okay, then you will get the complete solution or general solution over here. Okay, this one is your required particular integral. Earlier, before we found the value for complementary function, just need to replace over here. Okay, so I hope you all have understood this my today's lecture. It is completely based on the variation of parameter. Okay, how to solve the particular integral using variation of parameter. It's not that difficult. It is one of the easy method here. I hope you all have understood. Even after, if you found anything difficult, let me know in my comment section, guys. I will come up with the similar videos. Okay, I hope you all have understood. So thank you everyone. Thank you for my today's lecture.